Hey kiddos, here's the spiral review for spiral 11. We're going to start off with completing the square. This is the last time we're going to see this topic, so this is going to be definitely one you want to focus on, so if you did badly last time you can get your grade up. The process of completing the square is always going to be the same. Our goal is going to be to take something in standard form and make it into a perfect square that we can then use to graph much more easily. The first piece of this is to figure out what should my equation be. And if we've got 2x, I forgot my x squared, sorry, x squared plus 2x plus 5, the way you figure out what it should be is to look at the middle term. In this case, it's 2x. We're going to divide it by 2 and square it. That means that instead of plus 5, this should be plus 1. The reason that this should be plus 1 is we'd like to break this middle term up into two equal pieces so that this would turn into x squared plus 1x plus something. And two things that multiply to 1 and add up to 2 would be 1 and 1. Once we have that, to get from positive 5 to 1, we got to do minus 4 to both sides. So we got y minus 4 is equal to, in this case, x squared plus 2x plus 1. X squared plus 2x plus 1 factors into x plus 1 squared, and we still have y minus 4 on the left side. If you are having trouble figuring out where this comes from on the right side, you can either factor it out. It would be with the plus 1 there, and the first two would have x in common, so you get x plus 1, and then you got a 1 in common, so you get x plus 1, and that will leave me with x plus 1 times x plus 1, which is x plus 1 squared. Or as an alternative, whatever you do when you divide that middle number by 2, that's the number that ends up in the parentheses. Finally, I've got to get y by itself, and I've got x plus 1 squared and then plus 4. In graphing this, my vertex is the first thing we're going to go for, which is going to be at negative 1, the opposite of the inside, comma positive 4. So there's my vertex. Because we have a 1 out front, we're going to go up 1 over 1 on both sides, draw a nice parabola through those points, and we're done. The second part of this is looking at equations of circles. These are maybe the easiest thing we've done this year as far as just kind of getting something done. The big idea here is that the equation for a circle, which was really the Pythagorean theorem for a squared plus b squared equals c squared, tells us that we have a center that's at the opposite, so whatever would make the inside of each parenthesis equal to 0. So instead of negative 2, we're going to have positive 2 for x. Instead of positive 5, we're going to have negative 5 for y. That's my center. For the radius, that last term describes the radius squared. So if radius squared is equal to 9, that means that the radius is equal to 3. And when I plot those points, so we're at 2, negative 5, and with a radius of 3, so we're going to go up 3, I'm going to go right 3, down 3, and left 3, and try to draw some kind of a circle-like shape that makes sure I hit those 4 points. And we're done. Next up, we've got systems of equations. This is the new graded section this week. This is also one that we've really been struggling with, at least showing on your spiral. So I wanted to make sure that we talked a little bit extra about this, so I have a couple extra videos going on for this one this week. First thing I look at, I have a system of equations that looks like solving for either x or y would be kind of gross. And they're already lined up in x's and y's. They're both in what we call standard form. That means that elimination is probably a really good process for this. My goal is to make one of the coefficients, either in front of the x's or in front of the y's, the same as the other one. And I notice that if I multiply the bottom by 3, that'll make my y coefficients, both of them would be 6. So that would end up being 15x plus 6y is equal to negative 12. And if I copy down the other part of this, 2x minus 6y is equal to negative 22. At this point, all I have to do is add the two equations together. So we've got 17x plus 0 is equal to negative 34. And that means that x is equal to negative 2. If I plug this back in to solve for y, I might just use the first one because I've got smaller numbers there. We get 2 times negative 2 minus 6y is equal to negative 22. 2 times negative 2 is negative 4. If I add that to both sides, I get negative 6y is equal to negative 18, and y is equal to positive 3. For number 14, I noticed that I already have a y by itself. That makes this a really good candidate for substitution. And what I'm going to do is to plug that in to the other equation. So 7, instead of y, we're going to have 2x minus 6, and then minus 2x, and equals 18. If we distribute, we've got 14x minus 42 minus 2x is equal to 18. I'm going to add 42 to the other side. That's going to give me 60. 14x minus 2x is going to be 12x, and that gets me x is equal to 5. I can plug that back into the other equation. Y is equal to 2 times 5 minus 6. 2 times 5 is 10, minus 6 is going to be 4. The next one we have set up for video is number 17. This is one of the quadratic ones. These are all going to be really, really similar. So the process for this, if you can figure out what's going on here, you're going to be okay on the spiral. First thing I do is set them equal to each other. Both of them are equal to y. So I might set this as x squared plus 1. I kind of like the x squared on the left. It makes it easier for me. It's equal to 5x minus 7. I know to solve something with an x squared, I need to make one side equal to 0. So I'm going to add 8 to both sides, and that's going to give me x squared and a plus 9. And I'm also going to minus 5x from both sides. I'm going to do this both in the same step to save a little bit of room. And I don't know why I added 8. That should be adding 7. That's weird. Oh, it's because I got 7 when I did that. And in looking at this problem, I realized that I did not intend something to happen here, and this is not going to be factorable. The way I'm going to treat that is I'm going to go back and rewrite this as a 6. I think that's what I originally intended and typed it in wrong. And all that's going to do is change each of my 5s to a 6. And now this is nicely factorable. So that's going to be equal to 0. And once you get this equal to 0, that's when we factor. A times c is going to be 8. B is going to be negative 6. I'm looking for things that add up to negative 6 and multiply to 8. And that's going to be negative 4 and negative 2. So we've got x squared minus 4x minus 2x plus 8 is equal to 0. That means we've got x times x minus 4 and minus 2 times x minus 4 is equal to 0. That gives us x minus 4 and x minus 2 is equal to 0, and that would be x is equal to 4 and x is equal to 2. We do have to plug these in to figure out what y is, and when I do that, I don't know, I could use either of the equations. Let's say the top one, so y equals 6x minus 7. So we got y equals 6 times 4 is 24, minus 7 is going to be 17, and y equals 6 times 2 is 12, minus 7, y is equal to 5. That gets us our two sets of answers. We need one for x and one for y in each of those. looking at the word problems, we've got Niwa, who's an adventurous traveler. He skydives 2 times in every island he visits and 3 times in every peninsula he visits. He's gone a total of 25 times. Things that we don't know how many times he's gone in islands or how many times he's gone in peninsulas. So what we're going to be asked to do is find out how many islands and how many peninsulas he's visited. I'm going to do the work up above just because that's where this room is. Okay, I'm going to take a look at this sentence first. So he went skydiving a total of 45 times, and that's 2 times in every island. So I'm going to go 2 times, I'm going to call this I for island, and he goes 3 times in every peninsula, and 3p, and that's going to be equal to 45. The next thing, he visits a total of 19 islands and peninsulas. We often have a lot of trouble with making this equation, so that's going to be islands plus peninsulas is equal to 19. Something about the way that's phrased, since we don't see the math in the sentence, we don't want to, kind of like our brain doesn't want to think for that. But as soon as we have this set up, I can see this looks really good for elimination. I'm going to multiply the bottom by 2, and we'd get 2i plus 2p is equal to 38. The top one would still be 2i and 3p is equal to 45. When I subtract these two, we've got negative 1p is equal to negative 7. And that means that he went to 7 peninsulas. Please write the words for that. I'm not doing that right now because I really want to get through this quickly. And then the other part is if he went through 7 peninsulas, he went through 12 islands. Next up, we got properties of exponents and polynomial expressions. First thing we've got are some exponential things. So we're going to go category by category. Numbers first. So 2 times 7 is 14. X squared and x to the 5th. We're going to add those exponents, giving us x to the 7th. Y to the 5 and y. We're going to add those exponents, giving us y to the 6th. This one also has a z in there, but there's no other z, so that would just be z to the 5th. The key here is knowing that the numbers separate from the x's, knowing that this is not distribution, and knowing that we have to add exponents when we're multiplying. For number 25, we're dealing with both multiplying and dividing. I like doing the multiplying part first, and I'm going to recognize that this is 2 fractions being multiplied. The second one is over 1. I'm going to start with the numbers. 3 times 10 gives me 30. X squared and x to the 3rd would be x to the 5th. Y to the 5th would be y to the 10th. And on the bottom we'd have 5, x to the 5th, and y squared. 30 divided by 5 is going to be 6. X to the 5 divided by x to the 5 is going to be 1. Y to the 10 divided by y to the 2 is going to be y to the 8th. Sorry, there's supposed to be parentheses in there. And we end up with 6y to the 8th is our final answer. There were no negative exponents in either of these problems, but if you saw something, like if you had 3x, that's in highlighter, to the negative 4, that would then become 3 over x to the positive 4. For number 26, here we've got subtraction between them. Remember, this is not distribution, it's combination of like terms. X squared minus x squared would be, actually I'm going to write these out for us. X squared minus x squared would be 0. We've got negative 5x minus 4x, and that's negative 9x. And then we've got 1 minus negative 2, and that's 3. My final answer here would be negative 9x and plus 3. If I look at number 27, this one is distribution, and I know that because they were multiplied between them. These are the same exact two things that we had in the previous problem, but now we're multiplying. So let's go piece by piece. X squared times x squared would be x to the fourth. X squared times 4x is plus 4x to the third. X squared times minus 2 is minus 2x squared. Next up, we got negative 5 times x squared would be minus 5x to the third. Negative 5x times 4x would be minus 20x squared. Negative 5x times minus 2 would be plus 10x. And then we'll start with our ones. 1 times x squared would be plus 1x squared. 1 times 4x would be plus 4x. And 1 times minus 2 would be minus 2. I'd like you to notice that I lined these up based on whatever the exponent was, so we have some like terms. When I add these, we get x to the fourth. 4 minus 5 would be minus 1x to the third. Minus 22 plus 1 would be minus 21x squared. 14x and minus 2. At this point, you are done. There's nothing left to combine. And finally, we've got factoring and graphing polynomials, and we're going to look at the ones on the right side. So first of all, we've got to factor this thing in order to find the number and the actual values for the roots. I didn't leave any space here, so I'm going to kind of do this here. I noticed that all three of these pieces have an x. That means I'm going to start off by taking an x out of all the parts. So we get x, 2x squared, minus 5x, and plus 3. The inside of this is factorable, and it's going to factor into 2x plus 3, and 2x minus 3, and x minus 1. That means we have roots at x equals 0, that's for the first one. At x equals plus 3 divided by 2 is 3 over 2 for the second one. And x equals 1 for the third one. So we've got 0, we've got 1, and 3 over 2 is 1.5, so we'll draw that after 1. Okay, how many times does the graph intersect the x-axis? That's going to be 3. There are 3 roots here. Describe the end behavior. I'm going to wait till I graph that first. And when I graph this, since this is positive out front, I'm going to go up and to the right. And as I go through here, we have a nice smooth curve that hits all those points. Hopefully yours actually hits your points instead of drawing on a screen. And at that point, you're done with the graph. As far as the end behavior for this, as x approaches negative infinity, that means as x goes to the left. So as we go left, we're going down. Y should approach negative infinity also. That just means down. And then as x goes to infinity, that means to the right. And if as I go to the right, my graph is going up. That means that y is approaching positive infinity. All you have to do is decide if you were looking at the positive or the negative versions of these graphs. All right, the next one, we've got this in factored form is what we're trying to do. I know that my first 0, so that's at minus 3 comma 0, I'm going to do the opposite. So that'd be at x plus 3. And I know that for my next 0, I'm going to have x minus 2. I also notice that this one's bouncing off the x-axis. And because we're bouncing, that's going to be squared. And the last one, if we've got 4 comma 0, that's going to be at x minus 4. The last thing we need to do is decide if there is a number out front. I like calling that a. And to do that, we're going to plug in the y-intercept, which is negative 48. So negative 48, and that's going to be equal a times 0 plus 3 is 3, times negative 2 squared, times negative 4. And when I do that, I get a times 3 times 4 is 12, times negative 4 is negative 48. And if a times negative 48 is equal to negative 48, that means that a is equal to 1. So we have a 1 in front of this. At that point, your problem is done.